excited. I basically get paid to do my hobby. I just get to do awesome security research and then share with everyone, so yes. Okay, so thanks for coming, everyone. Let's talk about cross-site scripting. So this is in the top 10. We think it's bad. Let's talk about it. Okay, so here's the outline for today. We're going to talk about the OWASP Top 10 and how this is now A7. We're going to talk about what cross-site scripting is and how it happens exactly. We're going to talk about there's 3 different types. I'm going to make corny jokes. We're going to talk about what the risks are, like what bad things can happen and why you definitely need to fix this. We're going to do a demo. So my demo, I have to warn you, really sucks. So I had a demo plan that was really cute on my friend's vulnerable web app, and then someone hacked it so badly that it can't get back up right now. She has the flu, and she apologizes for not refreshing the data set for me. So instead I'm doing like a really crappy demo that's really basic, and oh well. So David's demo was really cute. How do we protect against this? So this is going to be almost the entire presentation. It's how do we protect against this, because this is why you're here, right? Because most of you, I assume, are ethical and don't want to attack things. What you want to do is create better code, right? So we'll teach you how to find it and how to protect against it. Oh yeah, and then how do you find it and test it, review your code for it so it doesn't happen to you in the first place. It says Q&A is at the end. But I'm a firm believer that if you want to just ask questions whenever you want, I kind of don't care as long as it's on topic. So just wave your hand around, or if there's actually a pause for a second where I'm not talking, you can talk then. Okay, so cross-site scripting and the top 10. So OWASP, as I hope all of you know, is an international nonprofit. We're a whole bunch of people obsessed with application security, and we do things like hold conferences, like I was at last month in California. We have chapter meetings like this. We create awesome tools like Zap. Woohoo! There you are, yeah. Yes, I love Zap. And one of the biggest things that we're known for, the most famous things, is called the top 10. So it is the top 10 worst vulnerabilities facing web applications, right? And we made this document so that people, well, not me personally, but we as a group, made it so that people would know where to start. But sometimes people are like, oh, it's a standard. It's not standard. And sometimes people are like, oh, we're OWASP compliant. No, that's not a thing. If a vendor says, like, we have an automated tool that can find all of the top 10, they've already told you they're a liar. It's really helpful. Anyway, the point of the story is that XSS, which is what we affectionately call cross-site scripting, is number 7 in the new release. It used to be number 3 and it went down because people started fixing it. Yes! The top 10's working! So this is fantastic. Okay, so this is what the new top 10 looks like. You would have seen Sharif last month, if you were here, go in a little bit into each one of these, and we're going to count them down. And why are we starting at number 7? Because I had a problem at work and I wanted to lecture someone about it, so then I made a deck about it because I'm like that, and then I was like, let's start at number 7, and then we're going to go to number 1 after. Are we doing injection next month?
Not next month.
Not next month, the month after? I hope it's in April, because then I'm going to see it.
In April, we'll do it in
Okay, so the next one we're doing is going to be injection. It's going to be Paul. Paul, put your hand up. It's the awesome dude that did the ethical talk a few months ago about why not to be bad with your newfound powers. Anyway, okay, let's continue. Okay, so what the heck is cross-site scripting, right? So it's an attack that is against web applications, and it has nothing to do with cross-site stuff, which I will explain. Basically, it's where somehow someone tricks your application into thinking that this script that they've put in is its own script and it should execute it in the browser specifically. So we're going to get into this a little deeper. So you don't execute it in the browser against yourself. That makes no sense, right? You want to get someone else to have it execute against them. And the malicious code can do anything that JavaScript has the power to do. So if you are letting your JavaScript access your cookies, then this bad code could access your cookies. If you have this vulnerability, it can do anything that JavaScript can do, which is terrifying because JavaScript is extremely powerful. Cross-site scripting is all over the place. It's really dangerous, and that's why we put it on the top 10. But we're going to get into that a bit more. I wanted to put graphics. So this is a lesson as opposed to a talk, right? And usually I just have pictures and jokes in my slides, and then I talk so people listen to me. So I tried to add slides, pictures, so it would be more interesting. I'm not sure if it worked. So the reason why cross-site scripting works is because the browser thinks the script is from your application and then it trusts it and it does it, right? So that's the problem. If it knew not to trust it, it wouldn't do it. So this happens when an app uses data that was not cleansed or validated and sanitized, and then it doesn't encode the output. It goes to the screen, it goes into your browser, and badness happens. So, like I was saying earlier, this means that the script can access your cookie, your session token, or anything else that your app has that you allowed your JavaScript to access. So we're going to talk about a header later that you can use so that it can't access your cookies. This last slide, or this last note, okay, so I've met a lot of software developers who think that cross-site scripting is a way that hackers make cute text box come up on the screen, and that they think that's the whole vulnerability. So whenever one of us, application security nerds, shows what cross-site scripting is, we always show you an alert box, right? And it's boring. It doesn't do anything malicious, and that's why we use an alert box. So you can visibly see with your eyes that it happened, and then it doesn't do anything bad, right? So I remember making like a framing attack and showing my proof of concept, and they're like, oh, but there's this yellow haze over the screen. We can tell that it's there. We can tell you're stealing our passwords. I'm like, I made it yellow so you could see it. So we make the alert box so you can see it. But that's not the thing that we're afraid hackers will do to you. We are not afraid that they will make an alert box that says Tanya's way cooler than you. We're afraid that they will do all the things you don't see. So I thought I would mention that. Okay, see the classic. Yeah, that's what we do. Okay, so more. So cross-site scripting is found in around 2/3 of apps. That's our estimate from OWASP. And you might be thinking, okay, so at the dentist they told me everyone has to floss their teeth, but lots of my friends don't floss their teeth and they still have teeth, so maybe it's fine. No. So the reason why it's so bad that it's so prevalent, that means that there's lots of automated tools to find it and exploit it. That means that, like that new thing that came out, Meltdown Inspector, those are really, really complicated vulnerabilities. You need a bunch of geniuses in a room working hard on it to exploit that. Any moron can do this. That's why it's dangerous and that's why it's scary. Because you can use XSS or like a million other tools to find it, and then there's so many different things that you can just download. 14-year-olds in their parents' basement definitely can totally do this. That's why it's scary. And they can cause a lot of damage. If you happen to be using an older framework, such as the bane of my existence, Struts, with Java. No offense, really. There's so much more weakness in this. So if you are using something, use the newest framework you can, because it's definitely going to be more secure against this. And we'll talk about some examples. Okay, bad code. Okay, so what do you need to have cross-site scripting happen? You need two things. You need data that you did not validate or sanitize. And you need to have not encoded your output or not escaped your output properly. And there's 3 types of cross-site scripting. So I'm going to just go over what they are, and then we're going to talk about each one individually. So there's reflected. So this is the really super common one. And we call it reflected because it bounces off of the web server. Oh, I have a cute little graphic. There we go. And stored cross-site scripting because it gets stored in your database. And it jumps out at someone else later. Great. And then DOM, which is the really weird one. Oh, not that type of DOM. Okay, so let's look at reflected. So like I said before, it bounces. So basically, unsanitized input, and this input can be from an API. It can be from other sources than just the user. It's not sanitized, and it hits the web server, and it's not cleaned up there. And then it comes back, and then attacks the user and executes it, gets them in the browser because it's not protected on the way out after. So in, it's not cleansed, out, it's not cleansed, or disabled, let's say. And the computer thinks the browser thinks it's part of your app, so it executes it. There's the little picture again. So this one specifically is usually where someone has clicked on a link on a malicious site or an email. I I've had a lot of people say like, oh, cross-site scripting, well, you need the other site, and like we're on an intranet, so that can't happen. But it doesn't need to go out to another site necessarily, right? Like it can still do damage against you. And so you don't need another site for this to work, but you need some sort of user participation in this one, for this one to happen. You have to click somewhere on something. The next one, you don't need user activity or user participation. So stored cross-site scripting, your application stores unsanitized data into your database for later as a surprise for someone else to discover. And then when your application goes and uses it, it's not protected against, again, it doesn't encode it, and it comes out and surprises the user that has gone to your site. So let's say you go to some site that you think you can trust. I want to give an example, and then I feel like I'm targeting whoever I say, but let's say you're going to go to the flower shop and you've been to the shop a ton of times, but if they have store cross-site scripting, like, it's not that you've clicked on a bad link, it's not that you've gone to some questionable page, you've bought flowers there before, and then it jumps out at you. And so this is something that users really, they can't see it coming, they haven't done anything wrong, not that clicking on the link is wrong, we try not to, but everyone makes mistakes, right? But I feel this is really, really dangerous. Like, I would say this is like a critical level of vulnerability if you have stored cross-site scripting in your public-facing website that has a PR disaster, you want to fix that immediately. System administrators are often the targets of attacks like this because they have all the power. They're the best types of people to attack, not because they deserve it, but because they're powerful. And so again, there's the picture. Okay, yes, so just to reiterate, the first one, a user has to click somewhere. For this one, because it's stored, the user didn't do anything wrong, and it's considered critical. Okay, so now let's go back to DOM. Not that kind of DOM. So the document object model, that's why it's named DOM, because the document object model is on the client side. But again, this is poorly named. Just like cross-site scripting, you don't need another, like you're not actually crossing two sites together. It's not actually necessarily in the document object model where the vulnerability is. It means basically that it stays on the client side. So it's almost like client-side script injection would be a more appropriate description of what's happening here, but maybe they felt that wasn't as catchy as DOM. So you don't need this. You don't need the server, like I said before. DOM-based cross-site scripting, from what I understand, is usually in a JavaScript framework. Like, those one-page web apps where everything just all happens, and they're like, it's too expensive to go to the server. We're just going to have everything so instantaneously beautiful, all moving in one page. It's really hard for pen testers to test those compared to the classic sort of go back to the server, back and forth, because we can get up in there and look in between. We have to do a lot more work, think a lot harder if we're going to do a one-page app. And basically, it's where you take user input and then dynamically use it in your JavaScript, and that is the danger zone. So DOM-based cross-site scripting happens during runtime. It is not saved for later. It's not stored on your server. It's in your browser. And what this means is it's a lot more difficult to sanitize, because I usually tell everyone you should sanitize everything on the server side. But there is no server in this equation, right? Oh. So I did a different version of this at work today. So I guess I took out that extra slide that I thought was bad. Okay, so let me tell you one more thing about this before we go on. So with DOM-based cross-site scripting, so when you're doing JavaScript, all in a big framework that's just on one side, you have sub-context, like you have context, then sub-context, et cetera, et cetera. So when you're trying to output encode something, so let's say you have CSS and it's in your JavaScript, you have to like double encode it, you have to change for all of your different contexts. And there's literally pages and pages and pages of it, of how to do it. It's really complex and it sucks. So I suggest that if at all possible, if you are going to do one of those one-page things, don't take client input and then just reflect it out. It's painful. Okay, so what are the risks? What are the bad things that can happen from this? Because as we saw earlier, it is more than just the word boxes, right? So people can steal your session cookie, right? That means someone could try to impersonate you. This is obviously very bad. Someone could deface your website. I took a course, it was really exciting, and I learned about this. And there's a forum, and I injected what looked like part of the web page, basically, with a enter your username and password and then a button to submit. And it was great. Then I did it, and I got a copy, and I was like, yes. And that did not take that long. So if you have this vulnerability, especially on something like a forum where you allow lots of users to freestyle, it can get bad. People could try to keylog you. Basically, anything that you've ever done with JavaScript for good, you could also do for bad. The opposite of whatever you've tried to make it do, bad people are trying to make it do that, is not ideal. This is the demo I was going to do. Instead, I'm going to do a different demo that seems so lame in comparison. I felt like David's demo was really good. But instead, we're going to see this. Let's make this bigger so you can see. So this is like a Google game to learn about cross-site scripting. And I'm going to do like the world's most basic demo. And I feel like I have to put this mic down because I don't know about this one-handed typing business. We'll see. Okay, so this is an input, and it is vulnerable to cross-site scripting. It's going to just execute our JavaScript that we're putting in because it didn't validate it, and it didn't encode it. It didn't do any of the things it was supposed to do. It just actioned it. Too many hands. Well, this is like literally really simple. It's going to take me 5 seconds. If I can spell the word correctly.
No pressure.
Yeah. So I feel like it's really hard to see in this little tiny box, and I'm sorry. This is what happens when like you practiced your demo like earlier today. So we're opening our script. We're doing an alert box, telling everyone OWASP is cool. Obviously, that's what we should use. And then we close the script. So it's really simple, right? You'd be surprised how many sites take this. So congratulations, you've won the alert. We've passed this lesson. But you see how fast that was? So like most sites you might think are not that vulnerable, you'd be surprised. You would really be surprised. I've definitely gone to developers' desks and they're like, no, I fixed it. And I'm like, no, you looked for the word script. You blocked the word script. And then I just did this other thing. Or I put it in the URL parameters instead, right? Like, this is really easy. All of you are definitely way smart enough to do this in your sleep. And so we need to protect against it. So let's go back to the presentation. And what is that beeping about? Okay, so you can pretend that it was a lot cooler, and that was part of my friend's prank. We'll just pretend that happened. Okay, continue. How do we protect against this? Because this is what we actually care about, right? No one really cares about the demo. Okay, so the first thing I want to do is tell you about the cross-site scripting prevention cheat sheet. So this is one of the amazing projects by OWASP. So this guy named Jim Minico was like, you know what would be great if we just had a cheat sheet on things that I want to know. So he started making this project, and now tons of people are contributing to it. And basically, if there's a thing you want to know, there's probably a cheat sheet on it. And instead of having to go through lots of articles and look up everything, they just lay out all the answers for you. And they have one cheat sheet for how to prevent cross-site scripting, and then they have a second cheat sheet about how to avoid cross-site scripting filters and do more adequate testing. And you can just copy and paste stuff from the filter and test your own app, or if you're a pen tester, web application tester, you can just copy and paste this stuff, and they have these wild, crazy attacks, and it's awesome. So whenever a developer's like, Tanya, I fixed it, and I'm like, awesome, great. And then I start copying and pasting stuff, and then I go back to the desk and I'm like, you made a blacklist, not a waitlist, which we're going to talk about now. So this is the URL. I know it's really hard, but just look up OWASP XSS, and then, or cheat sheet, and it'll come right up, don't worry. Okay, so the first thing that you want to do to protect against cross-site scripting is treat all data as though it's not trusted. So if you got it from the database, unless your app put it in the database and you know your app cleansed it before it went in the database, if it's coming out of the database and you didn't put it there, sanitize it. If it's coming from, do I have a bunch of examples? Wow. So if it's coming from an API, sanitize it. If it's coming from the user, definitely sanitize it. If it was in a parameter that you put in the URL, definitely sanitize it. Sanitize all of the things. Don't trust anyone. I know I sound paranoid and I'm a security person, so that makes sense, but you should be paranoid too. So do this with all the data, and then encode or escape the data before outputting it to the screen. Let's get more specific though. Let's make a plan. I have 5 steps for us. 1, validate, sanitize all user input, but just all data. 2, encode and escape if necessary, all output. 3, security headers. I'm just going to show you 3 today, but there's so many more security headers that I would love you to use, but I'm just going to show you 3 that have to do with XSS. Code review. So I don't mean you have to review all your code for everything, but come on, look at the inputs and outputs. We can do it. And then VA scans and security testing. So we're not going to get that deep into number 5 because we have limited time, and also I don't want anyone to go to sleep. You have a really great talk to look forward to after me by Sean. Okay, so input validation. So this is my favorite one ever. So in validating your inputs will literally protect you from so many things. I can't tell you this is the number 1 thing you want to do to protect against vulnerabilities. So ensure that the input that you are getting is what you expect it to be, right? So if you're getting a date, why is it 100 characters long? That makes no sense. Where are you getting that? Why would a first name have a greater than sign? That also doesn't make sense. Why would a currency field accept letters? Right? Like the part where the numbers go should just have numbers. So if you're getting things that aren't what you think you should, reject it. Input sanitization. Okay, so I guess my little things aren't going. But anyway, input sanitization. So this is slightly different. You want to ensure that the input that you're receiving is not going to cause damage to your application. So if you're expecting a date, again, 100 characters is probably going to cause an error, right? If you're expecting a name, you see a greater than, it could be a malicious script. This doesn't make sense. Why would you accept it? And lastly, if you have a really, really large number, it could cause a buffer overflow. If you're not using a memory-safe language like Java or newer things like .NET, Ruby, etc. So don't let in stuff that can cause your app to crash or have unexpected behavior. So we want to put those 2 together and basically use your framework. So how many people here program in C? Okay. You 3 are hardcore. If you program in something older like C, you have to be so much more careful about security. And that's why they're at the back. They're the badasses. But I like to program in newer things because I don't have to do that low-level, really hard stuff. Newer things like .NET, like the frameworks in Java, like Spring, Ruby, all those things, they're memory safe on purpose to protect you against so many of these things, and there are things in your framework to protect you, like .NET, there's the anti-XSS library, in Java Spring, you have JSoup, you have Janca. So use your frameworks and they will protect you. Don't write your own unless you have to. Originally these slides had like 40 slides about writing your own input, and I got a little crazy, and I was told no one would ever sit through that, so I restarted. So again, validate and sanitize all your data. I'm just going to go on to all the things you need to validate. Data from your application, parameters in the URL, data from an outside API, data from the database that you did not put there in your own app, so it might not have been validated properly the first time. A lot of people don't think of these things, and I just want to make sure you're validating everything. There's a lot of options for this, so again, use your framework. You can check your types, you can validate against the schema. There's all sorts of different options, especially regex, regular expressions, which are your friend. I had a whole thing on regex and making waitlists and blacklists, and I was also told that that was too long and boring. I'm trying to, I have a friend Rachel who has this amazing talk on regex, and I want her to come in and give like an in-depth talk on waitlisting with regex, and she's considering it. Like if you want to get really into the weeds. Okay, so number 2 of our plan, encoding and escaping. So encoding describes the file's characters as they're physically written in binary, so Unicode or ASCII. Right? You have 2 choices. And then escaping is basically where you take the power away from special characters. So replacing special characters with their XML, HTML, etc. equivalent. So the white space, the single space in URL is a %20. Right? So if you replace those, they have no powers anymore. Again, like before, we want to use our frameworks. We don't want to write our own if we don't have to. So I gave a bunch of examples here of what you can use to scope, do encoding and escaping. Writing your own on things like this really sucks. If you're working in C and you're a badass, that's good. I'm sure there are frameworks, but you just have to work so much harder in C, I feel. No, you don't, no? C has lots of stuff? Give her.
There's lots of good practices for writing C.
Yeah.
It requires a lot more attention, I would say,
Yeah.
than some of the other higher level ones, but it plays a role.
Yeah.
Just maybe not for the kinds of things you're doing.
No, C is important, don't get me wrong. It's hard.
It's not, no language is the right language always.
Oh, no language does everything. Like, I wouldn't want to write an operating system in like a big, huge, chunky, beautiful, new front-end framework. Yeah, for sure. We need C, don't get me wrong. I'm just glad it's not my job. It's hard. Okay, next. If you have to manually encode and escape, in body tags, you can change ampersands, you can change greater than signs. There are maps, or maybe a map isn't the best word. There's lots of reference material on how to do this. The key takeaway, in my opinion, is you must encode and escape everywhere, everything. When in doubt, encode it. Use your framework. If you don't have a framework, definitely look at the OWASP cheat sheet about this. And also, you can totally come to OWASP and you can try to chat people up about it, and you'll be surprised you'll find that magical person that wants to talk about this in depth with you. Okay, next, repeatability, right? So I only like to do things once if I can. I really like templates. So if you work at a place and you're the boss of your team, make a template. Test it once, make sure it's awesome, and then just have everyone reuse it. Don't make people think too hard if they don't have to. They don't have to reinvent the wheel. Make it easy to do, make it easy to do reliably every single time and effortless. And if you want everyone doing the same way, or organization-wide, it's really easy to test. Anyway, that's my boss thing. Okay, so special update, this should be capitalized. How do we do this in DOM-based cross-site scripting, right? Because the other two talk a lot about sanitizing things on the server, but there is no server in DOM-based cross-site scripting, so what do? Well, in my opinion, don't use unsanitized data in your JavaScript. So if you get it from the user, I would suggest not mirroring it back. If you do have to, definitely look at the OWASP cheat sheet, because I could just do 100 slides on that and bore all of you to tears, and I won't do that, but it's my request that you don't do it. Okay, now I can go back. Okay, so let's look at number 3, security headers. In my opinion, security headers are totally underrated. They're like seatbelts. Seatbelts are boring, they are not sexy, they're not exciting. No one's like, yes, I'm putting on my seatbelt, I feel awesomely safe, but you're way safer. They're there in case of an emergency. Make a habit of doing it, habit of using it, and then when the S hits the fan, you're all set, right? So security headers. HTTP only. So you can set this flag in your cookie, or set this flag for your cookie, and it will prevent JavaScript from accessing your cookie. This is important because if you have a cross-site scripting vulnerability, then it can't get out your cookie and can't steal your session, which is probably in your secure cookie. Good. Okay, number 2, XSS protection. So if someone has turned off this in their browser, it turns it back on. and it stops a page from loading if it thinks there's cross-site scripting in it, which is great. That's great. That's awesome. Thank you. Not 100%, nothing's 100%, but it's pretty darn good. But this one only really works in Chrome and IE, not IT, IE like Internet Explorer. Yeah. So this one's the best one. Everyone choose this. Content security policy. So you can tell your app what client-side resources it's allowed to use. So basically, you do this, and then you separate all of the ones, each one you want to do with a semicolon, and basically, this is like, it's hard to read, this is my example, but so set your source to yourself, unless you know you need to include scripts from somewhere else, right? And you can set it to a specific domain, like we'll accept scripts from me, and we'll accept scripts from, I don't know, whoever, Google, let's say, or government has like a toolkit for web experience, so from there or from me, and that's it. Those are the only scripts we're allowed doing. This will protect you against quite a lot of things, and it's kind of awesome. Oh, yeah.
Sorry, just a quick question for you, because we ran this the other day.
Mm-hmm.
Who, in your opinion, should set the CSP?
Oh.
Is that your sysadmin who like works on your Nginx? Is it your back-end developer, or is it like the meta tags in your front end? Because we've seen this fall through gaps in the world.
Yeah, so should it be? So he's asking who's responsible for setting this, because a lot of security headers can be set on the server, and then a lot of them can be set in your app.
And yeah, in the config, in the app, and then again, I think it may be down the front end.
Yeah, so who has to set it? I guess it depends. So until tomorrow at 5 p.m. I work for the government, and there we have a department that takes care of all of our servers. And so me being me, and I'm a control freak, I would set it in the app because I have control over the app. Right? But I know at a lot of places you have control over the server and the app. I call those places heaven. And then I guess if you have control over both of those things, then you get to decide. But I definitely agree that, do you want to chime in, Jeff?
I do. I think the app developer is the only one that knows what you need to include in the license, right? So if you need to include a different domain, cool. If you need to include a different domain, your administrator is not going to know that unless you go through it with a ticket and get them solved for you, right?
And I agree with that. It's just the challenge becomes like when you're starting to run in these Kubernetes environments and you've got different domains and you've got sysadmins who are responsible for multiple domains and you've got app developers responsible for multiple apps, and then you have somebody who has to oversee, fortunately, all that crap.
Right.
So then the question just comes in, as I said, it's the type of shit that falls through the manhole.
Yeah. We just use self, and that's it.
So you.
Yeah.
What if you have a template that is set to self, and then if you need to change it, you have to document it somewhere and tell someone, instead of just changing it and not telling anyone?
And pay them $1,000.
And then pay them $1,000.
Just to discourage them.
Just to discourage. Oh, you have to pay $1,000 if you change it from self.
Yeah.
I thought you meant, and then you pay them $1,000. I'm like, no, that sounds like the wrong types of motivation. Cool. Okay, next. Okay, so now we're on step. Where do we look? Right. So we're on step 4 now. So where do you look? You look in your code, right, for cross-site scripting. Look at all of your data. Make sure wherever you're getting your data from, you've sanitized it, right? So you don't, okay, so I think we should review code, we should all be well behaved. But if we're only talking about cross-site scripting, just review all your inputs and your outputs and make sure all output encoded, all the input sanitized. There's more things you should look for if you're going to do a secure code review, but that's not what this talk is about. But if you look at those things and you make sure you just are not trusting any of the data, and you make sure you encode it before you put it out, you should be in pretty good shape. And what else do? We test our code. So obviously the number one thing I think you should use is OWASP attack proxy, affectionately referred to as ZAP. But there's other options. There's paid options like Burp Suite, AppScan, Akinetics, etc. There's a whole bunch. And there are free ones like XSS, Vega, Arachnai. The point is, so as a developer, you can test your own code. I know that if you were kind of really locked down place, you might not have permission, but if you explain to your boss you're doing it for the good of your application and it pushing left, starting security earlier, means it's cheaper to fix the bugs now in the dev phase rather than later after it's in production and a bad guy or a lady has found it, right? So these are pretty easy to use. Most of them, they're pretty easy. Like, you can start Zap, you can watch a little video, and in an hour you can be scanning things. Only scan things that you have permission to scan, right? But testing your own code, I feel, is a really good way to get better at coding. It finds things for you, and then you're like, oh, that sounds bad. And then usually it gives you links on how to fix things. You learn so much, even if you just fix one of the things you find each time, right? So anyway, we are probably going to do something about Zap later this year. I'm getting the nod. But for now, these are some options. So, oh, and you can manually test your app. Yes, I forgot. So I personally suggest starting with a scanner because you don't have to think too hard, you don't have to know that much, and you can learn a lot, and it'll give you hints and clues. The best type of thorough scan, like when you get really good, is manual testing. Like you kind of graduate up the chain, but you still need a web proxy. Okay, enough, I'm good. Okay, does anyone have any questions?
I use the OWASP app tool to test for cross-site scripting. And then basically the report comes back and tells me, there's no cross-site scripting vulnerabilities on my site. How confident should I be that actually there is none on my website?
Okay, so the question is, if you use Zap and it runs a scan on your app and it has not found any cross-site scripting vulnerabilities, how confident should you be? Well, automated tools, it's estimated they find around 30% of vulnerabilities.
30%.
But that's of all vulnerabilities, not of specifically that one.
Yes.
Would you like to weigh in, person who programs Zap?
So there's no silver bullet. I would say for cross-site scripting, slightly higher than 30%, probably more like 50 to 60. But the other thing you can benefit from is using multiple tools, right? So use more than one tool. They have more than one signature. OWASP also has another good tool specifically for XSS called Xenotix framework, which actually has all three major web browser engines built in, and is really good at finding DOM XSS and stuff. Zap also has an add-on for DOM XSS that isn't included by default, so you can add it from the marketplace and try it. It'll actually launch a browser on your system, and it hooks into the browser and monitors for the alerts to pop up and stuff.
Oh yeah, that's a new update. I think I've seen that, yeah.
There you go.
All right, so not 100% confident.
I'm just going to quickly repeat what he said for the camera. So Zap will find more than 30%, but not 100%. There's no silver bullet. There's plugins that you can add to it for extra good stuff. Using multiple tools is advised.
So my friend Ron, who was at the back end of their bug bounty program for many years, basically says for Google, #1 by far is DOM-based, far exceeding reflected or stored by a very large percentage. So people, if you're only finding stored and across the end reflected, good, but you're probably not looking for the DOM-based, really should.
Okay, so the comment was most scanners are missing DOM-based cross-site scripting. They're finding reflected and stored, which is awesome, but there's still lots of DOM-based things out there, so you definitely need to do some manual testing. So, good summary. It's your turn.
Most of these prevention are for regular access. Is that also what's on?
Oh, so DOM-based cross-site scripting is really complicated, and you definitely do want to sanitize your inputs because it's all, but the best protection is just not taking input from the user and then immediately reflecting it to the screen, because if it doesn't go to the server, you can't clean it properly. Like, it's just so complicated, and definitely also with DOM-based cross-site scripting, you need to, so there's all these different contexts when you're working in a JavaScript front-end framework only. So there's context and subcontext, and then subcontext again. So you want to look at, there's an entire cheat sheet just for DOM-based cross-site scripting. So if you do need to reflect user input directly without taking it to the server where you can clean it properly, you definitely want to encode it over and over and over and all the different, it's very complicated, but you can do it. but I didn't go into it because I tried it on my team at work and it was not cool. Like literally their eyes were closed and they were like, why is she doing this? So, yes, I think, Adam, did you have something? No? Oh, it was you. Yes, please.
So you talked about what we should do if there is a hacker that he wants to
A
save.
little louder, please. I'm sorry. I'm having trouble hearing you.
Okay. You talked about the scenario where hacker wants to save HTML tags in the backend. So what would be the best practice if we as a developer want to save HTML tags in the backend?
You should escape them. You should escape. So the question was if you want to save HTML tags into the database?
Yes.
Yes. So you want to escape the data first so that it's, do you agree? Adrian, you're looking at me very
I was
seriously.
going to say don't do it, but
Yeah, so Adrian's like, don't do it, buddy. Definitely escaping things is good, right? You could also like just disarm it completely and just like take the commands out and then reassemble it later. It's a thing you could do. Like if you escape everything down, and can you like if you escape it and then save it escaped, and then when you bring it out, make sure that you properly encode it. Do you think you'd be okay?
But if you
I feel like I'm getting lots of. I don't think it's a good idea.
I would say a best practice is do not store data and code together ever.
Yeah. Okay. So a best practice: do not store data and code together. I like that. Whitelisting was another suggestion. Yeah. Maybe I don't know if that's great. Oh.
But what about sites like, for example, WordPress? When you sign up for WordPress and you create, for example, a new post, you're allowed to edit it in HTML. And it takes in HTML and you submit that through the browser. And I don't know where and how it stores it, but what do you do in that case?
Well, this question was about WordPress and is asking you're able to edit HTML inside of WordPress and it saves it. And Sean wants to answer this and he wants to hold the mic so I don't have to repeat it.
So in WordPress, what it does is blocks mainly the script tag from being saved to the database.
Okay.
Unless you are an administrator, that tag gets stripped out when you save your post.
I see. Okay, it makes sense.
And I will go into examples of how that works during my talk.
Awesome. Does anyone have any more questions or would you like to hear about how you can secure WordPress? No, seriously. Cool. Thank you everyone very much.